Okay, so today we're going to have a look at a new method of integrating, integrating by substitution. It should be familiar to you in parts, but it is a new method, so we'll have a go at that. Okay, so we're going to consider the integral, this integral, for example. It's got two parts to it. We've got this part here, and I might use a different color, and this part here. All right, so we're going to start looking at this first part. So we're going to consider it having the form f of u of x. All right, where f of u equals u to the power of 4. So we can consider this whole thing u to the power of 4, and u of x equals x squared plus 3x. All right, so that's how we're going to consider it. So the whole thing's to the power of 4, and that internal bit is x squared plus 3x. All right, so that we're going to consider that the first part. The second part, we're going to consider, so we're talking about the red part now. We're going to consider, so it's 2x plus 3, and we're going to look at that as u dash of x. So the differentiation of u. So that 2 would come down, so it become 2x, and the x would go away, so 2x plus 3. All right, so that's what we're going to consider, and this is the form that we have to have if we're going to use substitution. So we're going to consider this function, we're going to rewrite it. Oops, let's write it in black. We're going to rewrite it as the integral of f of u of x. All right, that's the first part, multiplied by the second part, which is u dash of x. So that's how we're going to write it, and this is how we have to have the form if we want to use this method. So I just forgot my dx there. So we don't have to prove this formula, but what we are going to do is we're going to consider this as the integral of f of u, and this second part we're going to consider the u dash du by dx. It's another way of writing the differentiation by dx. All right, now what we can see is these here are going to cancel. So by writing our integral this way, we actually can rewrite it as f of u du. All right, and we can use this formula here. We can use it to integrate these functions very quickly, actually. So if we consider our original function, we'll do this in blue now. We can consider this the integral of f of u by du. So our u was u to the power of 4. So that's what we're going to do. So it's going to be the integral of u to the power of 4 by du, which equals, when we integrate, we add 1 to the numerator, so it's u to the power of 5, and we divide by that, that power. All right, and that's, well, always remember we got plus c, and that's it. So all we have to do from here is substitute back in our original u, which was this. So this thing equals 1/5 of x squared plus 3x to the power of 5 plus c. All right, and that's done. So it takes a bit of rearranging at the start, but once you get there, it's quite a quick way to get to your solution. So let's have a look at another example. So using substitution to find the integral of this function. So the first thing we're going to do is we're just going to rearrange it. So we're going to rearrange it to be the integral of 1 over x cubed plus 2x times by x squared plus 2 dx. All right, and you might notice that we've got it here, our function, and this is the actual differentiation of our denominator there. What we can do is we can write this as integral of 1 over u du by dx and dx. Again, we cancel these out, and we've just got to integrate 1 over u by du, which is equal to the natural logarithm of u plus c. All right, last step is to substitute in our original u, so equal to the natural log of x cubed plus 2x plus c. Okay, so again, like I said, it's pretty quick once we recognize the type of function that it is. So one last example. I want to show you a bit of a different way to do it if you want to keep track. So what we're going to do is we've got the integral of square root of sine x cosine x. So we're going to let u equal sine x, and therefore the du by dx is equal to cosine x. So this is exactly the same thing we've been doing. So what we're going to do is we're going to get the integral from pi on 2 to pi on 6 of, let's jump straight into it. So we've got the square root of u times by du by dx. Again, we can cancel those out. We have to do a little bit of a tricky thing here and recognize that our square root of u is the same as u to the power of a half du. What we're going to get then is the integral of half is going to be, we add 1 to that and divide by it, so it's going to be u to the power of 3 on 2 divided by 3 on 2 from pi on 2 to pi on 6. All right, that's going to equal 2 over 3 u 3 on 2. So just move that 2 up to make it a bit easier. Okay, we then substitute our original u back in. And I'm not going to do that because I think you can, but basically the answer you're going to get is 2/3 take 1 on 3 root 2. Okay, but we've gone from a really tricky looking function to a much simpler way of integrating it. All right, so hopefully we can have a go at some of these now. So good luck.